We are PhD Comics.
And we want to know why. Today we are visiting the Jet Propulsion Laboratory in Pasadena, California, and asking the question, why are we sending another rover to the surface of Mars?
This is the most I felt like a real scientist in my career. Oversized bunny suit. We have found ourselves on the Mars Rover Lab test bed. I don't know what's the official name?
The Mars Science Laboratory.
Mars Science Laboratory test bed.
Yeah, we call this one the VSTB, for Vehicle System Test Bed.
And behind us is an actual replica with all working parts of Curiosity, which will be, knock on wood, landing August 5th successfully on Mars and taking us to the next level of science. So this is pretty much what is going to be landing on Mars.
Yeah, it's basically the only rover test bed we have. It's the only one with wheels and a full suite of avionics. It's been building up in various stages, but right now it's pretty high fidelity. We set up a little Mars environment here, like that, and like this little rock shrine, you know? And then we pretend like it's day 100 on Mars, and we have all the scientists up in the other rooms. They're not allowed down here. We turn off the cameras, and they're not allowed to see what the configuration is. We put little ducks, just for fun.
For fun.
So I can go a little closer because I've got what's called an ESD wrist strap. It makes me at the same voltage as the rover, so that no static discharge can jump across and fry any instruments.
Okay,
so,
I will stay at least a meter away.
So yes.
This one looks huge.
Yeah, this is the size of a Mini Cooper, and we're using a landing system that's never been tried before. Depending on who you ask, you get different degrees of confidence. It takes 15 minutes when you send the command through the dish at the DSN. What does this say? Yeah, we work a lot of hours. And then a Mars day is slightly longer than a Earth day, so we're always shifting times we start.
Why MSL? Why the big rover with the crazy landing system and the additional trip to Mars after two rovers have been there?
There's a couple of reasons. I think one of them is the previous rovers had about 5 kilograms of payload. That's the amount of science instruments they could carry. We're carrying about 80 kilograms of science instruments, so it's a huge, 16 times more payload that we're carrying. We also have delivered new capability on the rover itself. The drill, for example, is something we haven't been able to do before.
This is the end of the arm. You can see it's kind of like folded up like this. The biggest thing on the end of this arm is a big drill, and so when it grabs from the drill, sample of the rock that it just sampled, and then it'll come over here and drop the sample off into these funnels. They go inside the chassis of the rover and drop off into those instruments, and then they can do the analysis and they generate a data product and send it back to Earth.
What we're looking for is really the signs of habitability. Not whether life exists, of course, but whether could the potential for life be there. And a lot of that, of course, does still revolve around water, but a lot of that also revolves around organic compounds.
Its big Cyclops eye is actually a telescopic laser that they can focus and blast a hole in a rock. The fact that we have a rock shooting laser is the coolest thing about this project.
That is pretty amazing. It's almost Star Wars-esque.
Yeah. I got into this because of, I took an astronomy class at a community college in high school, actually. I just thought seeing anything move on this guy was the coolest thing ever, and it still is the coolest thing ever. But yeah, it's easy to lose track of how lucky we are to work here. And this thing always surprises people, and there's a lot of good analysis that goes into it, and it's just a coordinated effort to really understand how this thing works, and we've got a lot of good people working on it.
So how do you know it's all going to work?
Don't. We do lots of testing.